Hi there, this is your favorite 9 math channel, and let's see how we can solve this integral. So first I will introduce you a property, but it's quite easy to show that this property holds, so I will also show it. If I have an integral, definite integral fx dx, this integral is not going to change if I write a plus b minus x instead of x. So let's show this is true. So first I will just take this integral and play with it, and I will get this right side. Okay, so instead of x I will put a plus b minus u, just to make it look like this. Here x is just dummy variable, and instead of x you can think it like u. So now this part looks similar. I have dx is equal to minus du. So my bounds are also going to change. I have a, if I put x is equal to a, b is going to be equal to u, so u is going to be equal to b, and on the upper part I will have a, so my integral is going to be, instead of x I put a plus b minus u, and I have minus du, so I put minus du, and I know that if I change bounds of integration I will get extra minus, so this will be from a to b, f of a plus b minus u du. So this proves my theorem, this property. So let's see how can I use it. This property is especially useful if you have trigonometric functions, because this a plus b is probably going to add up to pi over 2 or maybe pi, and you may have something simpler. So let's see what would happen if I rewrite this integral. I have from 0 to pi, and so instead of x I'm putting a plus b minus x, which is pi minus x. So I have pi minus x, and so sine of pi minus x, so I have my x's between 0 and pi, so this will be between 0 and pi, and I know that sine function is positive on this interval, so this is sine of x 1 plus sine squared x. So this second integral looks a lot like my first integral, and the only difference is pi minus x and x. And here, if I just add both of these integrals, I will get rid of this x at the beginning. So let's call this integral I1 and this is I2. They are same, but I'm just doing this to distinguish them. So if I add I plus 1 and I1 and I2, I will get this part same, and it will be x plus pi minus x, so it will be just pi. So I have 2i equal to pi, and I have my bounds from 0 to pi. This will be sine x over 1 plus sine squared x. So I have a bit different integral, and it's a bit simpler because here now I don't have this x. And let's see how we can solve this and what kind of substitution we can make. So if I say sine x is equal to u, it's not gonna work because I don't have du at the top part. And if I make substitution 1 plus sine squared x is equal to something, it's still not gonna work. But I can make a clever substitution, and first I can just rewrite the sine squared as 1 minus cosine squared x, because then I will have 2 minus cosine squared x dx. And now if I make the substitution cosine x is equal to u, I will have minus sine x dx being equal to du. So now let's see what is my new integral. So my bounds are also going to change. If I put x is equal to 0, I will get 1. And if I put x is equal to pi, I will get minus 1. So I have this is equal, and I also have pi from this part. So my integral is going to be 1 over 2 minus u squared. And I also have dx is equal to minus du, so I can say there's a minus here, du, and now I can just change order of integration again. So I will get extra minus, which will be plus from minus 1 to 1, 1 over 2 minus u squared du. So here I have an even function, which means going from -1 to 0 and 0 to 1 for this integral is going to give me the same result. So I can say this integral is equal to 2 pi times from -1, sorry, I can just say, just pick this part, from 0 to 1 over 2 minus u squared du. So I started with 2i, and I found this thing. So let's just cancel these twos. So now I have, again, bit simpler integral. So we are going step by step. So I have I being equal to pi times integral from 0 to 1 over 2 minus u squared du. And we can solve this integral by fractional decomposition. And so I will write what 1 minus 2 minus u squared as, so this, if I just factor this thing, it will be square root of 2 minus u and square root of 2 plus u. So I can try to write, would this work if I write it like this, square root of 2 plus u. So this will be like this. I will have a plus, minus on the between, and I will get a constant here. So let's see what would happen if I just multiply this thing by this and this denominator by this thing. I will get square root of 2 plus u and square root of 2 minus u. So I will get square root of 2's canceling out, and I will have 1 over something u at the denominator. It will be 2u. But I don't want to have u at the denominator. I want to make this integral easier. So instead, I can just say this integral is u minus square root of 2. So I just multiply this thing by -1. And let's see, can I find such constant now? So if I multiply this thing by u plus square root of 2, so this will give me, let's do it, u plus square root of 2. And I will get minus u plus square root of 2. So I will have 2 square root of 2's at the top part. And now I can just delete this part. So if I multiply this by 2 square root of 2, I will get this top part same. And at the denominator, if I multiply this thing, it's u plus square root of 2 and u minus square root of 2. And if I multiply them, I will get minus of this thing. It will be u squared minus 2. So if I multiply this expression by minus, this statement will be correct. Okay, so I factored this thing out. And now if I rewrite my integral is going to be pi. And I also have this 1 over 2 square root of 2. I can just factor it out. It's just a constant. So I have integral from 0 to 1. And I have u minus square root of 2. Let's say this is minus. And I have 1 over square root of 2 plus u du. And now this is easy integral because it's going to give me ln, because I have just derivative of this part at the top part. So this is just minus ln of this thing, and this is just ln of this square root of 2 plus u. So I can just combine them by saying this is ln of u plus square root of 2, and this is u minus square root of 2. And I have u going from 0 to 1. So I can just substitute this in. If I put u is equal to 1, I will get ln of, I'm putting 1, so it will be 1 plus square root of 2. And at the down part, I will have 1 minus square root of 2, but this is negative. So, and I'm saying this is going to be positive, so it will be just multiplied by minus the down part. So this will be square root of 2 plus 1 over square root of 2 minus 1. And if I put u is equal to 0, this is going to be just 1, and ln of 1 is 0, so I don't need to write that term. So this is going to be my answer, and that's the end of it. Yeah, we can finish it here.